7.3 Trigonometric substitution. In finding the area of a circle or an ellipse and the integral of the form the integral of the square root of a squared minus x squared dx arises where a is greater than 0. If it were the integral of x, the square root of a squared minus x squared dx, the substitution u equals a squared minus x squared would be effective. But as it stands, the integral of the square root of a squared minus x squared dx is more difficult. If we change the variable from x to theta by the substitution x equals a sine theta, then the identity 1 minus sine squared theta equals cosine squared theta allows us to get rid of the root sign, because square root of a squared minus x squared equals the square root of a squared minus a squared sine squared theta equals the square root of a squared open 1 minus sine squared theta close equals the square root of a squared cosine squared theta equals a, the absolute value of cosine theta. Notice the difference between the substitution u equals a squared minus x squared, in which the new variable is a function of the old one, and the substitution x equals a sine theta. The old variable is a function of the new one. In general, we can make a substitution of the form x equals g of t by using the substitution rule in reverse. To make our calculation simpler, we assume that g has an inverse function, that is, g is 1 to 1. In this case, if we replace u by x and x by t in the substitution rule, equation 5.5.4, we obtain the integral of f of x dx equals the integral of f of g of t times g prime of t dt. This kind of substitution is called inverse substitution. We can make the inverse substitution x equals a sine theta, provided that it defines a 1-to-1 function. This can be accomplished by restricting theta to lie on the interval open bracket negative pi over 2 and pi over 2 close bracket. In the following table, we list trigonometric substitutions that are effective for the given radical expressions because of the specified trigonometric identities. In each case, the restriction on theta is imposed to ensure that the function that defines the substitution is 1-to-1. These are the same intervals used in section 1.5 in defining the inverse functions. Table of trigonometric substitutions. We have columns of expression, substitution, and identity. The expression square root of a squared minus x squared. The substitution is x equals a sine theta, and theta is greater than or equal to negative pi over 2, and theta is less than or equal to pi over 2. And the identity is 1 minus sine squared theta equals cosine squared theta. The expression, the square root of a squared plus x squared, the substitution is x equals a tangent theta, and theta is greater than negative pi over 2, but less than pi over 2. And the identity is 1 plus tangent squared theta equals secant squared theta. And then the expression square root of x squared minus a squared, the substitution is x equals a secant theta, where theta is greater than or equal to 0, but less than pi over 2, or theta is greater than or equal to pi, but less than 3 pi over 2. And the identity is secant squared theta minus 1 equals tangent squared theta.